Hi everybody, welcome to our NBS webinar today, Uniclass 2015 in practice. So a little bit of housekeeping just to start off. I'm the chair for the day, Stephen Hamil from NBS. Webinar is going to be about 60 minutes. We've got 4 speakers, so we'll get started as quickly as possible. Attendees' microphones are muted, but you can ask questions in the question box on the screen, and we'll follow up all the questions after the session. So, first speaker today is going to be Dan Haig from Environment Agency. Then we're going to hear a sort of Uniclass case study from Kathy Das, Palace of Westminster. Then we'll hear from Steve Tompkins, BESA. And then finally, we have a 4th case study from John Merchant, Geometry Gym. And then fingers crossed, we'll have 5-10 minutes at the end where we can do a bit of a question and answer. We can get it all done in 1 hour. But yeah, fingers crossed. But without further ado, pass over to Dan from Environment Agency. Over to you, Dan.
So thanks, Stephen. My name's Dan Haig. I'm an advisor in the Digital Asset Data and Information team at the Environment Agency. And what I want to talk to you about today is how the Environment Agency manages its asset information and where Uniclass fits into that. So just to give you a bit of background, the Environment Agency is a public sector body set up 25 years ago to protect and improve the environment. We have numerous responsibilities, including things like industry regulation and water resources management. But one of our key functions is managing the risk of flooding from rivers and seas. And we've managed to reduce the risk of flooding to 300,000 homes across England. So to help us achieve this, we maintain over 22,000 kilometres of flood defences and related assets. So that's things like embankments, walls, sluice gates and debris screens, etc. And this image at the top left is a sea flood defence being installed. So that's a major piece of infrastructure. We're also the navigation and harbour authority in some areas. So we have assets such as locks, docks, navigation signage and so on. And this image at the top right, I believe, is one of our locks on the Thames. And we also have a responsibility for fisheries. So down at the bottom, we have an image of a fish hatchery. And we've got other things such as rain gauges and flow monitoring stations and all sorts of stuff. So as you can see, there's a diverse portfolio of assets that we own and manage. So why do we actually care about these things? Well, we have an interest in assets throughout their life cycle. So for example, we operate and maintain existing assets and we undertake inspections of those assets to ensure they're still fit for purpose. So we need to know what those assets are, what they're made of, where they are, and how we expect them to perform. This then feeds into our modelling and planning work, where we look at the assets that we've got, and we can then identify gaps and areas for improvement, such as where we need major renovation work, or where we need a new flood defence scheme. And then we have the design and construction of new or upgraded assets, which we normally outsource to contractors. So we need to know what those contractors are doing. What exactly are they designing and building, and what materials are they using? We can then assess the costs and carbon impact of any planned works and sign those works off. And then when construction is complete, we take ownership of those assets. So we then go back to the ops and maintenance phase. So we need to understand exactly what it is we've taken ownership of. And it works the other way as well. So other organisations need to know what we've got. So local authorities or organisations like the Canal and Rivers Trust need to know what and where our assets are, usually where we've got shared interests and responsibilities. And the main problems we've had with this are inconsistency and lack of transparency. So for example, one environment agency function like finance will talk about assets in one way, whereas another team, such as the inspection teams, might talk about exact same assets in a different way. So we have siloed definitions, and that's never great if you want to get anything done efficiently. Lack of transparency is a problem. If we don't tell people what we want, then we can't expect them to meet our requirements, and that then creates a legacy problem. So for example, if our asset data requirements aren't transparent, then a contractor isn't going to describe the assets that they're building in the way that we need. And we then have to go and do post-construction surveys, which are costly and ineffective. So the solution to this is standardization and openness, and Uniclass codes play a key role in this. So to help us with this, we've developed something called the Data Requirements Library, or DRL, which I'll show to you now. So it sits on the web at environment.data.gov.uk. I'll just click over to this. So hopefully you can see this. So this is the DEFRA Data Services platform. And there's loads of things on here, such as data download services, apps, APIs, and so on, that cover various functions of the Environment Agency and other DEFRA bodies. And I'm not going to show you everything on here. You can feel free to have a look at it in your own time. So if I just navigate to the app gallery at the top, click on there. And then, as you can see, we've got all sorts of stuff on here: bathing water explorers, drinking water, fish explorers, and so on. But the first thing on the list is the Asset Data Requirements Library. So this is essentially our asset data standard, and it defines our asset types and the attributes that are associated with them. And we classify our assets in a hierarchical structure. So at the top level, we have what we call asset categories. And these are broad groupings of asset types, and these are the ones listed here. So for example, aids to navigation or defenses. So if I click on one of these, let's say MICA, so that's the mechanical, electrical, instrumentation, control, and automation assets. We've got various different assets that fall into that category. And each one of these assets has a Uniclass code. In total, I think it's 113 asset types that we've got. Each asset is comprised of a number of elements. So if I click on pump assembly. So this is the asset for essentially a pump for pumping water. And there's a bit of a description at the top. Some of the asset types have got diagrams and so on. And then below here, we've got a list of elements. And the elements are not always essential. Some are optional. A pump will always have a pumping station will always have a pump element, of course. And as you can see, each element has got a Uniclass code. So if I click on the pump element, again, we've got a brief description of what it is. And then below that, we have a list of attributes. So these are the attributes that we expect, that we require information on at various stages in the asset's life cycle. And the attributes have got this format details column here, which defines what we expect for those attributes. So in this case, it's a numeric field. So it has a maximum and minimum value. We also have things like pick lists with defined list of options. Text fields would have maximum length and so on. We also have this purpose column here, which defines the stage at which, sorry, I'm gonna have to re-record that. I don't want to talk about purpose. We also have this delivery column here, which defines the stage at which we require information on those assets, for those attributes. So for example, EA7 is the end of life, operation and end of life stage. EA6 is project closure. EA3 is design, and so on. So the DRL is essentially a big data dictionary that defines what information we need to know about the assets and at what stages we need that information. And the content of the DRL can be accessed via an API or via downloads in machine-readable JSON format. So our contractors and other data suppliers will use this to identify the information that they're expected to provide to us at particular stages. And they then send us that asset data in GeoCobi format, which is essentially a big structured spreadsheet. And it's all part of the BIM process. And because everything is standardized, we should be able to immediately understand and interpret the data that we receive from them. And we're also building some tools to automatically check the data for deviations from the DRL specification. And we can reject any non-compliance and send that back to the data supplier. I'll just click back to the presentation. So as I've said, we use Uniclass codes within the DRL data standard. And when we started to put this together, we had loads of gaps where we didn't have codes. So we've been working with NBS to classify everything. And we've had some really interesting conversations with the NBS people, trying to assign Uniclass codes to the different elements and assets, because we've got some fairly obscure stuff. So for example, this one on the left is called a drain down fountain, which none of us had ever heard of before. We had to do some research talking to our ops guys to find out exactly what it is and how it's used. And we ended up giving it this code here for for bell mouth outlets. We found that the Uniclass structure hasn't always fitted perfectly with our asset hierarchy, and there is some duplication in the codes that we've used, but overall, I think we've been able to match things pretty well. And NBS have been really accommodating where we needed to change things. So for example, NBS have recoded all of their fish pass elements based on our conversations. And one of the real strengths of Uniclass is that it's a common language that we and others use to identify things, even if we know them by different names. So this image on the right, not the cows, the thing under the cows is what we call a flood embankment. Other people might call it a levee or a dike. So the code is actually called by Uniclass known as levees, but it's the same thing. It's what we call an embankment. But because we refer to things by the code and not by a name, then there shouldn't be any ambiguity. And Uniclass isn't just something for the construction sector. We're also using it for asset operations as well. And it provides that bridge between the designers, cost consultants, operations, and others. So to conclude, the Environment Agency has developed an innovative way to standardize and communicate our asset data requirements, which can be used both within the organization and by our contractors and partners. And the Uniclass codes are a key component of this that help to reduce ambiguity and increase the understandability of the data. And in turn, this leads to cost savings and efficiencies and really helps us and others to make the most of our asset data. Thank you.
Yeah, thank you very much for that, Dan. Without further ado, we'll jump straight across and now hear from Kathy Das from Palace of Westminster. Over to you, Kathy.
Hello everyone, I'm Catherine Das, you can call me Kathy. I'm an architect within UK Parliament. I work within in-house services and estates with knowledge in digital technologies, laser scanning, heritage and conservation. I've been engaging with NBS Uniclass team, BIM for Heritage Group and our project consultants to incorporate items relevant to heritage environment while developing BIM requirements for architectural fabric conservation. What we are looking at in this presentation is classification for existing building. In this instance, it's a Grade 1 listed historic building, a World UNESCO Heritage Site which is recognized worldwide. As most people are aware, the Palace of Westminster is looking to start a major conservation and restoration project known as the Restoration and Renewal Program, or R&R, which is meant to start in a few years' time. Before works can begin, I work on the business as usual side of the organization, looking into how we can record, manage, and maintain our assets to path the way for this major R&R program. Moving on, it's like, why do we need this? The images on your right-hand side, from left to right, the first image is an encaustic tile, which is you can find in quite a number of historic buildings. Fireplace, Scott's post-war door handle with daisy screws, Big Ben itself. So the bell is what is called Big Ben, and very often people refer to the tower as Big Ben, but the bell is what Big Ben is. And the clock tower is actually called Elizabeth Tower. And the far end corner image is the great clock face after its restoration. I started by adding all items within our estate on an internal non-exhaustive, it is called Managed Asset List, or internally it's known as the MAL. These items range from the macro historic building elements to micro furniture and fittings. It is important for us to use Uniclass classification to align our BIM strategy to achieve future digital blueprint. By recording and cataloging existing assets, it will facilitate a structured data which will be discoverable by a database search, enabling smooth progress for upcoming R&R. I realized that there were gaps in Uniclass for heritage items, for example, encaustic tiles. I got in touch with like-minded people within R&R program and BIM for Heritage Group, to name a few Middlesex University and Historic England, and we looked at what was missing. I used the Palace of Westminster as an example, as we needed a solution now. I contacted NBS and explained our challenges and discussed way forward, working in collaboration with in-house teams, R&R, BIM for Heritage Group, and NBS. We had on-site meeting pre-COVID days, of course, with NBS to get a feel of the environment and to get the bigger picture of what we are dealing with. I then shared a list of items that we could not find any suitable classification on Uniclass. Some items were very specific to the palace, so NBS had to look for ways to address this, something more generic that other organizations or people with similar environment will be able to use. Historic items need multiple information to be integrated, as there are various other legacy data required, for example, the architectural period, the age, origins of the material, the condition, and so on. The introduction of properties and characteristics. The introduction of properties and characteristics table is something new that will be introduced by NBS. We were given the privilege to test this to see how it could work. NBS says I've used the PC table in anger. I was desperate to get the additional layer of information onto COBie, and the PC table using attributes was the vehicle to enable this. It was satisfying for NBS team to see the function and the use of this new table to us. But to us, it was the missing link for the extra layer of information required. This is to illustrate an example of how using Uniclass to identify various assets in this space. This is a familiar space. People are used to seeing it on TV, social media, and some people have the privilege to have walked around the space. There are lots of information that can be captured within this space and linked to facility management database, facilitating better information management, and eventually creating a digital twin. The table on the left is an example of how Uniclass can be used to itemize the space, looking at the bigger picture of the space itself, to what goes on within the space using activities, followed by systems that are used for operational purpose, and adding on to the details of individual products involved. The Bell system code is a new code added by NBS after our engagement, which is what I highlighted it in red. This will enable recording of existing items to facilitate cataloging, which will be discoverable by the database search. This will enable a structured organization and management of assets. We are still at this infancy stage of testing how it will all come together, but it's showing positive signs at the moment. Moving on, this is a typical COBie spreadsheet workflow showing how data are linked from a model to COBie, something familiar to people working in the BIM environment. The colors identify the teams responsible for the information. For example, yellow designers are responsible, and the green items where the contractors are supposed to produce the information. And the blue lines with arrows identify how information are interconnected between the different tabs on COBie spreadsheet. This is kind of a typical use of BIM. BIM is mostly used in new build, and focus is mostly on MEP elements of a building and for its life cycle maintenance. Besides the MEP data, there are lots of information produced on a project as part of the deliverable of a building element. However, building information modeling becomes obsolete asset after completion if the data collected from the building elements is not used post-handover stage. Again, a reminder of what we are looking to achieve here. Our aim is to link relevant information to existing historical asset using Uniclass classification. There is no straightforward answer as to how to link heritage or significant data with COBie. The best way is to identify at the start of a project if it's a listed building. As such, most items will have historical significance. And in order to include extra information, which will enable heritage or significant data to be embedded, attribute would be the best place to include additional information. This additional parameter kind of a simple yes or no for each asset would be a useful start. If it's a yes, then you can apply the additional conservation parameters. This is a case study to prove that architectural conservation works data is equally important for future maintenance and asset management. This project was a pilot project to repair and conserve this hidden gem to its former glory. By carrying out conservation works to a trial bay of a fragile and little-known lavish medieval cloister, 500 years after it was first built. The Parliament's in-house services and estates team combined state-of-the-art conservation technology with traditional stone carving expertise. The scope of works involved stone repair, stone cleaning, window conservation. This project provided a fascinating case study of the interplay between politics, heritage, space, and technology. This will fulfill our public duty of care for future generations. We need to preserve and conserve this cloister to the best condition and gather all possible information. The image here kind of shows the condition of the works pre-conservation versus post-conservation. And there's an extract of how it looked like before the works began. The starting point is to understand and analyze the existing asset before deciding what to do and how to deal with the scope of work. We need to provide a list of conservation design requirements to gather the right information required. For example, historic cultural value and significance of the space to understand how it was used, understand historic building condition by doing investigation, analysis, and survey works, the construction method that was used, architectural character to understand the period it was built, building composition, and all relevant data to understand the building fabric and the implication for the actions to be undertaken. This will help to define a clear scope of work. Why is this important? I will pause for a moment for you to read why it's important. Moving on. On this slide, the orange flags refers to the conservation design requirement as previously mentioned. The extract of the plan highlights the area of this pilot project, and the image on the right is an extract of the outstanding outcome post-conservation works. The following slides are built up of layering information showing potential use of BIM and Uniclass in architectural conservation. I do apologize in advance that it starts to get a bit complicated. I'm trying to put in something which is multiple layer into a simple slide as possible. On this side, the gray section are the information currently gathered on projects using classification for COBie. I've included some Uniclass codes as an example. The codes in yellow are new codes provided by Uniclass following our collaboration, which will also benefit others. Zones usually used for fire, security, and etc., but adding a historic protected zone will be useful for other organizations with similar needs. The red arrow are indication of how the information are interlinked in COBie as previously shown in the table. Uniclass has classification codes that could be used from inception of a project to handover and in use of a building. The use of classification, in my opinion, is underutilized. This slide is starting to get busy as I'm trying to show what would be the multiple layer of information on one slide. The section in teal are classification that could be included in any project that will provide additional relevant information. These are codes already exist in Uniclass. I begin by including complexes that is linked to facility which can include the cultural value, significance, and the condition, followed by the area in focus, which is the space that works would be carried out. Here, it would be useful to include zone, where information about the construction method could be useful. This information could be gathered from conservation management plan. This will inform the activities that need to take place, which will help in definition of the scope of works. This information can be included via links. Moving on to the scope of works, it involves the facade showing the architectural character, which is part of the building element, which are then part of system involving various other information for the scope of works involved. Types and component goes into detail of the composition. All relevant information are linked back to documents showing what is done and used. Documents can be linked to products and systems involved. The introduction of PC table, which is properties and characteristic tables, as I mentioned before, is a missing link that enabled the additional information that was required for architectural conservation works. The navy blue sections are additional heritage attributes parameter, which is the vehicle to link the conservation data parameters. Using attributes, we were able to embed further information with regards to architectural period, original age, condition, and what has been done. This slide summarizes examples of the code use, and the highlighted codes at the bottom are some pending information. We are still in discussion with NBS. That was it. Any questions?
Thank you very much, Kathy. That was fantastic. We move to our next presentation, which is from Steve Tompkins from BESA. Over to you, Steve.
Okay, thank you, Steve. As Steve said, my name is Steve Tompkins. I head up SFG 20 for the Building Engineering Service Association. SFG 20 itself is a recognised standard for plant preventative maintenance in the industry sector. Today I'm going to talk about industry data structures and SFG 20's work with NBS in collaboration to use Uniclass 2015, and also the national rules the new rules of measurement, I should say, from the Royal Institute of Chartered Surveyors, and also CIBSI's Guide M in terms of the Chartered Institute of Building Service Engineers. So SFG 20 has been working in collaboration with NBS, RICS, CIBSI on the unification of industry data structures. The objective of utilising these established data structures and common language throughout the asset's life cycle without disrupting their original purpose and current application. These structures aligned provide a standard map naming convention supporting industry foundation standards through NRM, SFG 20 and CIBSI data, which can be used for future construction projects. Relational asset structures used through building and asset lifecycle phases. Bringing together these structures significantly enables the reuse of asset information throughout the various stages of asset lifecycle and brings information from different disciplines into a collaborative working environment. So you can take the 3D from using the NBS Uniclass structure, the 5D cost estimation for use with bills of materials or bill of quantities from NRM, and 6D in terms of SFG 20 maintenance requirements, which can be quickly mapped to using these data structures, and also life cycle and asset capital planning using design life guides from CIBSI. So what does this do for the industry as a whole, unification of these structures? Well, these structures support the use and transaction of data throughout the complete asset life cycle, as I described previously. And this is obviously from initial inception through to disposal. The use of these common data structures enables facilities and individuals to share data through a data exchange and throughout the whole asset life cycle at various stages in various levels of detail. For instance, asset information modelling from BIM projects can be used throughout the life cycle to provide 5D and 6D cost information and BIM modelling. It can assist with project handovers into operation and maintenance. Obviously, on the graphic there, you've got soft landings, but this is a transaction whereby you've got the structures to enable the reuse of information. It can be used as a basis of tendering maintenance and also renewal of works. Asset structures for condition capture or condition survey. Asset structures for life cycle renewal planning, and setting up computer-aided management systems or CAFM systems, or even other software systems, and transacting its data so it becomes consistent throughout the life of the asset. As an output of the collaboration, SFG 20 is now referenced in the BIM toolkit, detailing SFG 20 task codes and short asset descriptions, enabling users to see asset maintenance requirements referenced within the Uniclass structure. Within SFG 20, we've developed an asset mapping solution This enables users to upload asset data either in a spreadsheet or a digital model, an IFC file, and it will auto map SFG20 schedules to those particular data structures. Where Uniclass or NRM is used, it speeds up the application and mapping of SFG20 schedules to an asset portfolio, and allows you to capture things like the facility that it sits within, the space, and also the asset detail, whether it sits within a particular system. And also you can capture 3D models using the IFC format. We also have the capability to capture things like Matterport captures for historic buildings where there might not be a 3D model. So that's incorporated within our new asset mapping solution. In terms of SFG20 itself, we've also developed a number of other products that when combining gives a powerful output and the use of asset mapping. One product is Resource Modeler. So Resource Modeler is a cost application on SFG20 tasks, which gives a cost output by asset. Therefore, when you use the asset mapping tool functionality, possibly within a design phase or early stages of preliminary concept, you can actually model what the potential costs would be associated with that particular asset throughout its life in terms of its maintenance requirements. Or you could even use that information to assist in operational planning, data analytics, prediction versus actual, and identifying potential improvement opportunities, things like processes such as option appraisals or sensitivity analysis. This kind of modeling supports that. In addition to asset mapping solution, we also have software integration with third parties, so data can be transactioned through SFG20 into third-party softwares, making it easier to reutilize data into actual operation. So that's our current developments today, and that's a very quick introduction. If you want to find out more information, I can take you through SFG20, or you can contact one of our team, and I'm happy to take questions.
Well, thank you very much, Steve. Very interesting. Now, our last presentation of the day comes from John Merchant. He's going to look at data modeling, 3D modeling, classification, and he's from Geometry Gym. Over to you, John.
Thanks for the introduction, Stephen, and thanks for the opportunity to talk today quickly about the topic of Uniclass 2015 and how it relates to building information modeling. My name's John Merchant. Geometry Gym's a business that I started nearly 12 years ago, and it evolved out of projects that I did as a structural engineer with a computer science degree. We do a mix of software development in the form of plugins and consultancy, and that is a strong focus on interoperability and building information modeling and structural analysis, both in the context of buildings and infrastructure projects. So today I'm going to quickly demonstrate how Uniclass 2015 relates to the industry foundation classes, which is an ISO standard created and maintained by Building Smart for digitally describing the built environment. We're going to look at how classification's managed in a popular modeling application, Revit, and some enhancements and tools that we're doing, particularly relating to infrastructure classification. And we're going to use the information requirements specified by Transport Agency Transport for New South Wales here in Australia as the basis for doing this. There are similar information requirements around the world, and this isn't a Transport for New South Wales presentation. I'm just using it as a basis of demonstrating how Uniclass can be applied to a model. So this is Revit. It's a software application about 20 years old. It's been developed with a strong focus on modeling buildings. If you go have a quick look at how classification is managed out of the box, then the key way is really a two-tier or two-generation classification called categories and subcategories. It's kind of a constrained list of categories. It's a mix of products and systems and entities and not particularly well. There are much better ways, such as using Uniclass, to manage classification on a project like this. You can manage classification out of the box, but more on products and relating them to types. And there are a few other plugins and stuff or approaches for doing something similar to what I'm going to show today. Just quickly though, if we export IFC or an industry foundation class out of the box here in Revit, then what we end up with is a file sort of hard-coded relating to a building. So here we can see a breakdown of an IFC file with the concepts and the relationships that exist between them. So I have a site which might have a building, which might compose a number of building stories, which then might contain elements or products and systems relating to that. You can also have other relationships like properties and connectivity, which can be presented within that IFC data model. If we have a quick look in a viewer, so this is BIM Vision, which is a free IFC viewer, we'd see here a site. We can see here that this entity is being classified as an IFC building within the IFC classification, not a bridge. We can see building stories, but then we can see the products and that within there. So I guess what we want to focus on today is how we can use Uniclass to give a superior classification, but also automatically map that to the right IFC classes so that we end up with an IFC bridge in the new infrastructure extension, not an IFC building. So we have a plugin that we're developing, and if we're going to store the facility classification, then there's a data object in Revit called project information. And here you'll see I've actually loaded in a bunch of Transport for New South Wales properties and an export property for IFC, but I haven't yet started to fill in the values. So that's what we're going to quickly use this plugin and tool to do now. At the moment, I'm loading 2 classifications locally off the hard disk, but this information can be sourced from a cloud service like the Building Smart Data Dictionary. And here you would see then the different tables within Uniclass where we could expand and go find a classification concept that we want to apply to this concept. We can also search. So if I type in bridge, it will filter this. We could go look under entities, find fixed bridges, and then we can nominate about where we want to store or what parameters or properties we want to store this classification data in within Revit. So here I'm going to use 2 parameters, and you can see here we've already done some mapping, so we can relate that this classification code relates to the concept in IFC bridge, so we don't have to manually classify this object twice. So if I click under manage, I can click under project information, and now we would find that the code and the title and the export as parameters have started to be filled in by that particular change to the model. We could take a section and say we don't want building stories, we actually want to identify these levels in Revit as sub-facility parts. So again, we can do something similar where we can say we want to classify the element. I could go search for, say, substructure. Under elements and functions, we could find the classification code for substructure and assign that. You can see here I've set up some tags with attributes to show the classification code that dynamically change as I do this. So if I classify for superstructure, I'll get a similar result where I can say I want to call that superstructure and assign that to the element. We can then also say classify the element assemblies like the piers or the abutments at the end of this. And at the moment I've got an element assembly to group the products together to form that particular object. So again, I could say I want to classify the elements. I could look for abutment. Okay, and I could search under element functions and find under bridge structures, here's an abutment code. So I'm just going to store this in a slightly different parameter because there is a distinction between spaces and locations within elements within the way that the Transport for New South Wales want this. So actually I should have done this one as well, so I'll quickly classify that, and then I can do the same thing for the piers to classify them as well. So as I said, I'll quickly classify that as an abutment. You can see here that relates to a predefined type in IFC, element assembly in IFC, and then I can select the piers and I can classify them as a pier in the same way. Now, when I come to classify the products, then I'm going to actually apply that rather than have to select all the instances. I'm going to do that on a type basis. So for example, here I could say I've got my rectangular columns as part of the piers, and I want to apply a classification to that particular type. So again, I could then search in for column and see under products table, under structure, we would find a concrete column as a classification code that we could apply. Now you can see here it's using a slightly different name of a parameter because I'm assigning it to a type, and we can do the same with, say, classifying the footings. So if I type in pad, we could go under products and we could find under structure, support, base and foundation products, we could find a concrete foundation pad. Okay, so we've managed to sort of apply at least classification to part of the model. Revit's not as well developed in terms of managing systems. It says it has some systems built in for distribution, but I'm not going to go into that level of detail in this short presentation. So now if we're ready, we want to have a look at what these changes have managed to do. We have our own Export IFC Enhanced, which allows us to take advantage of the new infrastructure extension, which is currently at a release candidate to be published hopefully as a final standard later this year. We can nominate here this path of where I'm actually referring to the local classification definitions, and we can then say we're going to source those classification codes from these two different parameters that I filled in those values for. So I'm going to write this file with that particular data model, and you'll see then when it's finished. And then if we have a quick look, I'm going to open this in our free IFC tree viewer and have a quick look at it here. So what we would see now is we have a site still, because we didn't reclassify that, but then we have an IFC bridge, and we could then have that is broken down into two facility parts of type substructure and superstructure, instead of having a building and some building stories. And you can also then you can actually source the file using the different classifications. So we could see here we have one fixed bridge, and we can actually browse down to see the bridge that relates to, and we can have the element functions. We can see the substructure and superstructure. We can have a quick look at this then in the browser, and again then we'd see we have an IFC bridge instead of an IFC building, and then we have our facility parts and then our assemblies underneath. So that's a quick introduction to Uniclass and classification in Revit relating to infrastructure. We're doing a lot more work on this, but we're certainly interested in feedback. So if you have any of that, or you'd like to ask questions, you can do it now, or you can get in touch with me on any of the means below on this slide. Thanks very much.
So hi everybody. We've got Steve, we've got Dan, we've got Kathy back together, and we've also got Sarah, head of classification at NBS, who's sort of glued everyone together today. So hi Sarah as well. I'm going to ask questions with yourself, Steve. Most of the audience watching, I think, are the sort of the NBS audience around specification. What's your message to them? Should soft landings, the in-use phase, be something that specifiers can just give that a little bit more consideration to?
Yeah, most definitely. The soft landings principle, I'm going back a number of years now when I was actually on the construction side and working with construction teams. And the soft landings, when I was actually applying it, was a significant benefit, especially in terms of things like value engineering and so forth, where actually you're engaging with the operations and you could see the impacts of what design changes were. So I would advocate, obviously, continuation of use of soft landings, but this modeling that we've done in addition, in terms of the unification of these data structures, it allows the ability to talk in a common language and cross disciplines in terms of being able to actually have that information available. So with the SFG 20 code specified in the NBS toolkit, now gives you a direct reference to what maintenance could be applied to that asset in terms of what's that going to look like in terms of operation. And using SFG 20, you can quickly analyze and bring up what schedules will be required. So I see them as very much complementary.
Yeah. And just moving across to yourself, Dan, I've been watching the Environment Agency sort of API open data library stuff develop over the years. I think it's fantastic, and like just flicking through some of the apps on bathing water and drinking water and fishing and things. But in terms of the the sort of data structures for the data definitions, do you find that you could have one unified classification system that's not just for buildings, but goes across the entire country infrastructure?
Yeah, absolutely. So that's kind of what we do in a way. We treat buildings as just any other type of infrastructure. So in our data requirements library, we have a category for buildings, and that's got things like offices and laboratories and so on. And we treat them in exactly the same way as the other asset types. So these are things that somebody designs, constructs and manages in exactly the same way that we design, construct and manage something like a flood defense or a pumping station. And in our data requirements library, we break down those assets into elements. So some of the elements are unique to buildings, so things like doors and windows. But then you have other things like foundations or electricity meters that could apply to other asset types as well. And they've all got Uniclass codes, of course. So something like a foundation element would have the same Uniclass code, whether it's on a pumping station or on a laboratory. What you can't do is look at a Uniclass code and identify that it's a foundation for a building or a foundation for something else. So that's the hierarchy of Uniclass doesn't quite work in that way, but that works quite well for us in a way because it gives us the flexibility to associate various different element types with all sorts of different assets. So it works well for us. So to answer your question in one word, yes.
Yeah, I remember when we were first sort of scoping it out back in sort of 2014 or so, and we had a sort of rail example where it was a cut through of a rail track, and you had things like fencing and excavation and foundations and retaining walls that could be used just around a building as well.
Yeah.
But then you had things like the rail track and the ballast and the wiring that was specific to that sector, that part of the country's infrastructure. And I guess the similar principle.
Exactly, yes. So we've got things on pumping stations which you'd only get on a pumping station, but there are other parts of it that you would find on all sorts of different asset types, and we use the same Uniclass classification codes work for it all.
Yeah, and I love the fact it's in like the public domain. I've zoomed in on the map of the country and gone to sort of the River Wear next to where I live in Durham, and you can see the embankment and the fish pass and the weir and things, and really good. And maybe moving on to yourself, Kathy, I love the examples from the Palace of Westminster, the bell communication system. I can just imagine that getting rang and the different politicians coming in and things. But yeah, I understand it's a sort of pilot project that's going to lead into this data actually getting captured. And so where are you at, and where do you hope to go with that?
We are hoping that this will kind of show an example that architectural conservation works could embed a lot of BIM data. So as I mentioned before, usually BIM is focused around MEP. So we are learning along the process, and I was kind of adamant to try this on this particular trial bay. It's a small section, but it kind of proved that it can be done, and the information will be really, really useful going forward to help with the R&R project as well. So that eventually, it's kind of taking baby steps, but eventually it will lead on to a bigger compilation of information. So very often heritage requirements tend to be a plug-in later on in the project, which will then escalate the cost. So I think it's quite important for people to look at the nature of the building or project they are working on. If it's a listed building, then all these things needs to be thought of in the beginning, not a plug-in at the end. And of course, it's quite important to get the right people to do the job. Otherwise, and also to understand why you want the data and what you're going to do with the data later on.
Yeah, and just moving to yourself, Sarah, you work with like such a wide range of client groups, from police to transport to schools, the Palace of Westminster. Well, what are the sort of classification codes that you've seen over the recent months and years from Palace of Westminster across the different tables that are a bit sort of unique to that sort of heritage project?
Well, it's been absolutely fascinating working with all these people, and it's taken the team into worlds that we had no comprehension of in the past. And as Dan mentioned, there are things that turned up that none of us had come across, and it took a little bit of working out to find out what we could do. But at the Palace of Westminster has been an absolutely fascinating thing. I felt so privileged to be able to go around the houses with Kathy into some of the areas which aren't necessarily always open to the public, and to see all this historical heritage content, and to get an understanding of the fact that every single item has to be catalogued in a way that can then be, they can capture it by photograph, by description, and then hence adding in the properties and characteristics table so that we can identify the period at which some of these things have come from, has just been fascinating. And thank you to everybody for taking us into worlds that we knew nothing about before. So that's been wonderful.
I wonder if that sort of heritage type modelling would be useful for like other estates, like cathedrals. And I'm thinking about hometown here in Durham, and they never stop working on the cathedral grounds and the castle and Palace Green. And I guess it's a similar task.
It's 100%, yes. And some Kathy uses examples to us like those tiles that she highlighted, which are used in all sorts of places, cathedrals, historic homes, and castles all over the place. So it is all information which is going to be useful throughout the world who are looking after our historic properties.
Oh, fantastic. Okay, well, thank you everybody for their time today, all of the speakers. I'm going to pop the slide up now and just sort of do a sort of a wrap up. Thank you very much. Yeah, so hi everybody, that wraps up the presentations today. Just a little bit off me at the end. First of all, where can you actually download the Uniclass tables from? If you go to the nbs.com and just look across to the right hand side here, this is the Uniclass 2015 area. The tables are all free to download, Creative Commons, there's a little widget there as well, and you can sign up at the bottom here for updates on when the new tables come out. But one case study we didn't do today, but I was tempted to slot in, was this big presentation in Japan last week at their sort of ministry, and this is actually like Uniclass 2015 codes being used with all the Japanese language and character sets, which is quite fascinating. Got a little blog post on that if you sort of Google it. If you want to see any of our previous webinars, if you come across to NBS and come across to the events here, every webinar we run, and we've run over the last 12-13 months, you can come and just sort of watch on demand. In particular, the Construction Leaders Summit. That was our two-day event 2 or 3 weeks ago. And if you want to know more about the NBS products, you've got NBS Chorus, where you can write specifications, Uniclass 2015 format, and NBS Source, where you've got loads of manufacturer content, Uniclass 2015 format as well. So just to sort of wrap up, the final slide, visit our website, which I've just shown. Get in touch, pop something in the chat box, give us a ring, drop us an email, pop something on social media. And if any of your colleagues want to watch this presentation, it'll be on that events page, and we'll drop an email through when that's ready as well. So thanks very much. Bye-bye.